From 2012 to 2016, you are on a fast track. Your knowledge is on fast track. Here we go. Yeah. Don't say that word.
Hello. Hello. Yeah. Good afternoon to all ladies and gentlemen. I am Jayavardhan Reddy from Enmax Engineering. Enmax Engineering is located in Suraram JD Metla, established in 2007. I am in this field, heat recovery field, since 2 decades. We manufacture only heat recovery boilers for different applications. One is clean gases, second one is dusty gases, third one is corrosive gases. So we are specialized in all type of fuels. So far, we fabricated, designed and fabricated more than 200 boilers in span of 10 years. We supplied in India as well as exports. Our main boilers goes to Bangladesh, where there is a lot of demand for the exhaust gas boilers for the gas engines. It is a clean gases. The power, the steam used for either process or power generation. So recently we have supplied on 6 megawatt based power plant, which generates medium pressure of 25 bar and 320 degrees centigrade. Regarding the dusty gases, we are supplied for ferroalloy furnaces, annealing furnaces, then sponge iron boilers, coke oven, carbon black, and different applications. Apart from the manufacturing, we also design heat recovery boilers for MSW as well as coke oven and carbon black, only designs. In designing of boilers, since there is no sort of time, I want to brief only, my section is codes and standards. In codes and standards, not only for designing of boilers, there is a regarding mechanical, coming to thermal and mechanical. So thermal gives the construction of basic design of the boiler. Basic design of boiler means what is the number of tubes, tube size, length, and what is the velocities and other things. Code of constructions gives the thickness of the different components. If you take the boiler, in boiler you have a different components. Coming from steam drum, there is a risers, downcomers, and economizer, evaporator, superheater, condensate preheater, different sub-equipment. So each equipment will have their own process. One is for, suppose if you take condensate preheater will preheat the condensate from certain temperature to certain temperature, then it goes to deaerator. From the deaerator again comes to economizer. Economizer will have its duty is to preheat water from certain temperature to certain temperature, then it goes to evaporator, steam drum, then there is a risers and downcomers, evaporator, and goes to superheater. So to design the steam drum, we need certain parameters. One is pressure, another is a temperature. So based on the pressure and temperature, then there is a diameter. Pressure, temperature, diameter will give the thickness of the steam drum. So if in India we follow IBR, 1950 is the regulation, whereas for other outside India is a ASME, suppose if it is a DOS, Malaysia DOS, German DIN, BS, different codes will follow. So each code specifies what is the minimum thickness required for the certain component. Suppose tube, if you calculate the tube thickness, it comes 0.2 mm, 0.5 mm, but code specifies minimum thickness will be 3.2 mm. Not only, we will not follow the 3.2 as the basis. Based on our experience, past experience, then we go for higher thickness, because there is a lot of corrosion elements you have to consider, then erosion you have to consider, thinning you have to consider. Those factors you will not specify in the codes. If you take in IBR is the only code we have in India which specifies all material requirement, welding requirement, heat treatment, radiography, that means NDT, all other. If it is in ASME, we have different sections. Suppose ASME section 1 gives the construction of the boiler, only construction of the boiler for the power application. Then section 8 is the non-pressure, non-power, non-fired. Then section 2 is the material specification. Section 9 is the welding. ANSI B 16.5 is the selection of the walls, flanges. Then coming to performance, it is a PTC 4.1 and 4.4. 4.1 fired boilers, 4.4 is the unfired boilers. So we have different codes. Whenever we design boiler as per Indian conditions, we will refer some parts in the ASME also. Because to design the steam drum thickness, we require stress. Stress value will not available in the IBR code. Then we have to refer to ASME section 2A. As the temperature goes on increasing, then stress value is decreasing. So we have a different type of material. Based on the temperatures, we will select either carbon steel, alloy steel, stainless steel, Incona, etc. Now, here the basis of selection of material is carbon steel. In the IBR, it is specified. If it is if you go to section 2A, then allowable stresses are given certain temperature. If you go to ASME B 16.25, it specifies you will not use prolonged temperature more than 1100 degrees centigrade, 1100 degree Fahrenheit, like that they will specify. We will follow the same codes for all type of boilers. For this code is immaterial for different applications. Either it is MSW boiler or conventional boiler, other boilers, codes remain same. The only thing is our experience we are adding, our past experience. Suppose in MSW boiler, ABC boiler, why you have to go for 6.25 mm, 6.5 mm thick bed coils, even though the calculated thickness is 0.2 mm, because a lot of erosions are there. To increase the life of the bed coils, we are going for higher thickness. So each components will be designing as per this, but whereas in the boiler we have other components like non-pressure part, ducting, structure, civil. Those things will not covered under this code, IBR code or ASME code. So you have to refer for other codes. Similarly for piping, analysis, because if the temperature increases or temperature difference is there is a differential expansion, then the differential expansion will not cover the IBR. You have to refer other code. So piping we will go for a flexibility analysis with the different software. Similarly for structure we go for a analysis for the different code. So the difference in previous section, so one of our gentlemen asked why the boiler size is more in MSW boiler when compared to the conventional boiler. So it is part of thermal design. The MSW boiler, these two factors, one is area and another is velocity. Two factors are contributing to increase the boiler size compared with the conventional boiler. One is area. Area, nothing but Q equal to UA LMTD. Q is the heat load. Whether it is a conventional boiler or MSW boiler, Q remains same. U is depends upon the overall heat transfer coefficient. What velocity is selected. This velocity varies from boiler configuration to boiler configuration. If it is a clean gas, we will go for a higher velocity. If it is a dusty gas, erosion gas, then we will go for a lower velocity. If the velocity is higher, then your heat transfer coefficient is more. If the velocity is lower, your heat transfer coefficient is lower. So, similarly, LMTD. LMTD is the log mean temperature difference. It gives the temperature difference between gas temperature and steam or water temperature. Suppose In MSW boiler, in MSW boiler, there is a limitation on pressure and temperature. The pressure restricted to 45, temperature restricted to 410. So, it's not the restriction of the steam pressure. So, we have to restrict the gas temperature also. If the gas temperature is higher, then your metal temperatures are higher side. So, whatever I selected the material, code specified 410, can use carbon steel. But since it is MSW, and your temperatures are higher side because of the either corrosion or erosion. So that time your LMTD, that time whatever you selected carbon steel is not suitable. But as per our theoretical calculations, it is selected material is okay. But practically the metal temperature is going higher side, then whatever you selected carbon steel is not suitable for that particular temperature. That is that code will not specify that. So that comes from our experience. We are restricting the gas temperature to 600 degrees centigrade. Because of restriction of the gas temperature, your LMTD will be lower side. So your equipment is coming bigger side. Other side, you are burning low calorific value. That means you are generating more amount of gas. You are generating more amount of gas, and the gases are going at lower velocities. Since the gases are going lower velocities and your heat transfer coefficient is less, that also contributing more. It's not 20%, almost it goes to double. Because LMTD is poor and U is poor. Because of that, we are not able to accommodate the bundles in the second pass or third pass. Then we have to go for a other section, either it is horizontal or vertical. Then we have to go for another pass. If you are going for another pass, again it is increasing my structurals, civils. So this is also contributing to increase the price of MSW boiler. So after construction of boiler, then it goes to erection. From erection, then it comes to performance testing. So performance testing also there is a standard for PTC 4.1 and 4.4 direct method and indirect method. So direct method is amount of fuel you have to measure, you have to measure the radiation loss, you have to measure the other losses. Indirect method is you are burning this much fuel, you are generating this much heat. That is heat loss equal to heat gain. So indirect method, mostly we will go for indirect method. It is easy because in the proposal stage itself we will specify this is the gas outlet temperature. So we will show the gas outlet temperature, we will show the steam generation, steam pressure and temperature according to that code. So thank you to WTERT and Mr. K.S. Rao for giving opportunity to introduce our company and to give some lecture on codes and standards. Okay, thank you.